In section 6.5, I want you to be able to find roots, real roots, so that means there are no i's, imaginary numbers, by factoring polynomials, and also identify multiplicities. So first let's talk about what a root is. The root of an equation is any value that makes the equation true. So if I said x plus 2 equals 0, then negative 2 would be a root, because to solve this I would subtract 2 from both sides. To identify how many roots a polynomial has, we want to look at its degree. If a polynomial has a degree of 3, then it has 3 roots. The other vocabulary we need to talk about is multiplicity. And you can probably see this is from multiple times. It's the number of times a root of a polynomial appears as a factor of the polynomial. So here is an example. If we look at this graph, because it bends here and does not go through, it has a multiplicity of 2. The graph touches and it changes directions. If the graph bends as it goes through, this is a multiplicity of 3. So if it touches and turns, basically, it has a multiplicity of 2. If it bends as it goes through, it has a multiplicity of 3. Now, if it's a line that just goes right through, that has, I'm just going to use m, a multiplicity of 1. Okay, now we want to talk about even and odd roots. When a root has an even multiplicity, the graph touches the x-axis but does not cross it. So this would be your even. It has a multiplicity of 2, and it touches but it doesn't cross the x-axis. When a real root has an odd multiplicity greater than 1, the graph bends as it crosses the x-axis. So this is odd and this is odd here, so that's the bend that you'll see for an odd multiplicity. Okay, now we want to talk about factors versus roots. So a factor would be something like x minus a. A root would be something like x equals a. So here, if I have a root, this means x equals 3. I bring it over to the other side, subtract 3 from both sides, and I get the factor. If I have the factor, if I set this equal to 0, I bring it over, so I'm going to set this equal to 0, bring the 4 over, and the root is x equals 4. So x, this is the factor part. We just, when we find the roots, it's like setting it equal to 0 and solving for x. So if I think of this as being equal to 0, x is going to equal negative 5. And if I think of this as being x equal 2, and I want to write it as a factor, I just bring that negative 2 over to the other side. So I add 2 to both sides, and it'll be x plus 2. All right, so now we are going to find all the roots. So we want to know everything that we can plug into here and get a true statement. So the best thing to do is always set the polynomial equal to 0. That means you want all the terms on the same side. So I'm going to subtract 24x to the 4th. And now I will write it in standard form. So this will be 4x to the 6th plus 4x to the 5th minus 24x to the 4th equals 0. Okay, now after I've done that, my goal is to find a number that I can put into everywhere I see an x and get 0 as an answer. So if I had you do that, you'd probably be guessing for a while. We can use algebra to figure it out more efficiently. So when I'm using algebra, the first thing I'm going to do is we're going to factor, which means we take out the GCF first, just like we've been doing for the last week. We're going to look at all of these, and I can see if I look at the 4 and the negative 24, the largest number I can take out of all of them is 4. And then the highest value of x is also 4. So that's going to be 4x to the 4th. So when I divide this by 4x to the 4th, that's going to give me x squared plus x and then minus 6. Okay, so this is my greatest common factor. Now think back to we did in section 6.4. After we pulled out the greatest common factor, if it was 3 terms, we made it into 4 terms and factored by grouping. So off to the side here, I'm going to do a times c, which would be 1 times 6. That sum to b, which is 1. So factors of 6 are 1 and 6. They're 2 and 3. I need to multiply so I get 6 and add so I get 1. Oh, actually, this is going to be a negative 6. So 1 times negative 6 equals negative 6. Let me just write it back up here so it looks a little easier to read. That's kind of scrunched up there. All right, so if I multiply together, I need to get a negative 6, which means one of these numbers has to be negative, and then I need to add to get 1. So if I make this 2 negative, that'll give me negative 6 when I multiply, and it will give me 1 when I add. So this is the combination I need to use to break this term up. So we'll write x squared minus 2x plus 3x. So this equals plus x. I haven't changed the value of it at all. And now that I have 4 terms, I can factor by grouping. So here I can pull out an x, and I have x minus 2. Here I can factor out a 3, and I want to put a plus 3 there. And grouping again, I have x minus 2, which I can pull out, and I'm left with x plus 3. Okay, now you want to remember to bring down this 4, x to the 4th. Okay, this is a factor, and this is a factor. Now this says to set each factor equal to 0. So 4x to the 4th gets set equal to 0. X minus 2 gets set equal to 0. And x plus 3 gets set equal to 0. All right, if I divide both sides by 4, I'm going to get x to the 4th equals 0. And here, if I add 2 to both sides, I'm going to get x equals 2. Here, if I subtract 3, I'm going to get x equals negative 3. So these two are easy to see. This is x equals 2. This is x equals negative 3. Now I have x to the 4th. That means I have 0 4 different times. So we said that the degree tells you how many roots you should have. My degree here is, let's go here, it's a degree of 6, so you need 6 roots. Okay, so here are 2, and this means that I have 0 4 times. So I have, if we would take the 4th root of this on both sides, we would still get 0, but that's saying that there are 4 zeros. So what we do now is we say that we have list our roots as we have 2 with a multiplicity of 1. We have, because we only see it one time, we have negative 3 with a multiplicity of 1. Extra x equals 3 there. We'll cross that off. All right, and then we have 0 with a multiplicity of 4. So when I add all of my multiplicities up here, I should end up with 6. So I have 2, that's with a multiplicity of 1, 3 with a multiplicity of 1, so that makes 2, and add 4 to it, that gives me 6. So if I would write it all out, it would be 2, -3, and then 1, 2, 3, 4 zeros. But we don't write it out like that. We just say multiplicity of 4. Okay, so any one of these numbers that you substitute back into this equation will give you 0. Okay, just a few reminders here. When factoring a polynomial equation, always remember to take out the greatest common factor. Look at the number and the degree to decide which factoring method to use. Refer to previous sections of notes for factoring techniques. When solving a polynomial equation, set each factor equal to 0. And then when identifying multiplicities, determine how many times the identical root appears as a solution. Okay, now you have a few to try.